Hi grade 11. So today we're doing lesson 5.8, solving 3D problems using trigonometry. There's a handout on Teams that you should print and fill in as you watch this video. So at the top of your handout there's a box that says key ideas. And I'll just read through that for a minute. It says, to solve a 3D problem, you need to be able to find the common side that connects triangles in different dimensions. Then use the three tools we've learned. SOHCAHTOA, don't forget about the cast rule, sine law, and cosine law. So we're going to do 3 examples using those 3 things, and hopefully that will help you in solving your homework questions. So example number 1. When flying in a plane over Prince Edward Island, it is possible to see all the way across the island from one side to the other. The pilot of a small plane spots the western edge of the island at an angle of depression of 61 degrees and the eastern edge of the island with an angle of depression of 3 degrees. If the plane is flying at an altitude of 10.5 kilometers, how long is Prince Edward Island? All right, so if this is the plane flying along, and the plane stops here, and it's 10.5 kilometers up in the air. That's how high it is. And the question says, the pilot spots the western edge of the island at an angle of depression of 61 degrees. So we're going down to the west, and the angle of depression is 61 degrees. So that's the angle from the x-axis looking down. The angle of depression to see the east end of the island is 3 degrees. And that's the east. All right, so I'm just going to connect this there. Now, altitude of 10.5 kilometers, and we need to find how long is Prince Edward Island from the west to the east. So we need to find this length here, and I'm going to call it x, and that's all the way from one side to the other. Okay, so how can we find any angles inside this triangle? Well, using angle rules that you learned in grade 10, we can find this angle here and this angle here. So using the Z pattern, we can determine that the west angle is 61 degrees, and here as well, the east angle is 3 degrees. So now we have that, and we know that this forms a right angle, and we know the height is 10.5. So we can start by finding this length here, which I'm going to call h for hypotenuse, and then because we know 3 degrees here, the height is 10.5, we can find this one using SOHCAHTOA. And then we'll be able to find length x using this angle here and the side lengths and the sine law. So, starting with SOHCAHTOA first. We have this angle 3 degrees, we have the opposite side, and we want the hypotenuse. So opposite and hypotenuse is sine. So we'll do sine 3 equals the opposite, which is 10.5, over the hypotenuse, which is h, we don't know. So we want to get h by itself, so we're going to multiply both sides by h. And then we have h sine 3 equals 10.5. We'll divide both sides by sine 3. H equals 10.5 divided by sine 3, and that is, in your calculator, 200.62 kilometers. I'm just going to draw what I know again. 10.5, 200.62, 61, 3, and we want x. Okay, so now we know this side here. We want to find x, and we know these 2 angles. So we can use the sine law, which says sine A over A equals sine B over B. So I know angle 61, and I know its opposite length, so I can use that one. I have that pair. Now I want to find this side length, so I need to use this angle up here, which I can find. So we're going to call that angle P, as an airplane or pilot. And every triangle adds up to 180 degrees. So I can do 180 minus 61 minus 3, and that leaves me with 116. So that angle is 116. So now I know sine A will make 61A. So sine 61 over A is 200.62 equals sine B, which is 116, over X. So X equals, we'll cross multiply and divide, 200.62 times sine 116 divided by sine 61. Punch that into your calculator and you will get 206.2. Therefore, Prince Edward Island is 206.2 kilometers long. All right, question number 2 says, 2 roads diverge in a wood at an angle of 39 degrees. 2 hikers traveling together decide to split up at this point. The first one heads down one path at 6.2 kilometers an hour, while the other hiker moves down the second path at 5.4 kilometers an hour. After traveling for an hour and a half, the first hiker shoots up a flare that rises 800 meters into the air. How far apart are the 2 hikers at this point? With what angle of elevation does the second hiker see the flare at its highest point? So, they're walking down a path, and there's 2 roads that go in different directions, and the angle between them is 39 degrees. So, the first one heads down one path at 6.2 kilometers per hour, and the second one moves down the other path at 5.4 kilometers per hour. They travel for an hour and a half, so I'm going to multiply their speed by an hour and a half. And that will tell me how far they've traveled. So 5.4 times 1.5 is 8.1. And the other hiker is 6.2 times 1.5, and that's 9.3. So he has walked 9.3 kilometers, and this one has walked 8.1. So I'm going to connect that. I'm going to label this triangle A, B, C. And I need to find how far apart they are. So that would be side A. There. Call this one side B, and this one side C. So I know side angle side. So that means I can use the cosine law to find side A. So A squared equals B squared plus C squared minus 2BC cos A. So A squared equals 9.3 squared plus 8.1 squared minus 2 times 9.3 times 8.1 times cos 39. 9.3 squared is 86.49. 8.1 squared is 65.61. And then 2 times 9.3 times 8.1 times cos 39 is 117.085. Add and subtract those and you will get 35.015. Take the square root of both sides. A equals 5.9 meters. So we know they're 5.9 meters apart. Now, if they're 5.9 meters apart, and this hiker shoots a flare up in the air 800 meters, I need to find what angle of elevation does the second hiker see the flare at its highest point. So I need to find this angle here, which I'm going to call theta. Now before I do that, I need to change 800 meters into kilometers because we need to be in the same units. So 800 meters in kilometers is 0.8. Now I can just use SOHCAHTOA to find the missing angle. So Looking at angle theta, I'm talking about the opposite side and the adjacent side, so that would be tan. So tan theta equals opposite over adjacent, 0.8 over 5.9. So theta equals tan inverse, 0.8 over 5.9. Punch that into your calculator, and that's 7.7 degrees. So the second hiker sees the flare at 7.7 degrees of an angle of elevation of 7.7 degrees at its highest point. All right, number 3. Bob is trying to find the height of a large tree. He knows that the angle between the closest point to him in a row of trees, 70 meters away, and the large tree he's interested in is 37 degrees. He also knows that the angle of elevation from the ground to the top of the tree is 13 degrees. So, if I have Bob standing here, and here's the row of trees, he's 70 meters away from the row of trees, and that's on the ground, so he'll form a right angle, and that's 37 degrees. Then the largest tree is right here at the end. So that's the tree. This will also form a right angle, and this will be 13 degrees. So in a situation like this, you would be given this information. You wouldn't have to come up with this drawing on your own. Some you will, but this one's worded in a very confusing way. So if that happens, you would be given the drawing. All right, so we need to find the height of that tree, x. So I can start by finding this length here, and then I'll have enough information to find x using the other triangle. So I'm going to call this one y. Now, to find y, I'm going to use the angle 37, and I also have 70. So 70 is adjacent to 37, and y is the hypotenuse. So adjacent and hypotenuse, I would use cos. Cos 37 equals adjacent over hypotenuse, which we're calling y. I want to get y by itself, so I'm going to multiply both sides by y. So cos 37 equals 70. Sorry, y cos 37. Now divide both sides by cos 37. And y equals 70 over cos 37. In your calculator, that is 87.65. So this one here is 87.7. Now, using this triangle here, I can find x, and I'm using the 13 degrees. Y is adjacent, and x is opposite, so I'll need to use tan. Tan 13 equals opposite over adjacent, so x over 87.65. Multiply both sides by 87.65. And x equals 87.65 times tan 13. Punch that into your calculator, and you will get 20.24 meters. Therefore, the tree is 20.24 meters tall. All right, so I hope that helps for your homework. Let me know if you have any questions.